Alright, so now we're talking about the properties of fluids. So some properties of fluids, one being viscosity. Viscosity is a measure of the resistance of a fluid to flow. So viscosity describes a fluid's internal resistance to flow and may be thought as a measure of fluid friction. So friction, again, is something that we learned from our last unit, and it's coming up again and again. So it is commonly thought of as thickness. So viscosity is correlated with thickness. If we think of soda pop, it is thin and it has a low viscosity, whereas corn syrup is thick and it has a high viscosity. If you look to measure viscosity, it can be measured using a ramp method. You pour the different liquids down the ramp and time how long it takes each of them to reach the bottom. The one that is the slowest is the most viscous. So, as a reminder, increasing the temperature of a liquid lowers its viscosity, so it makes it thinner, where decreasing a temperature increases viscosity, making the liquid thicker. So temperature and viscosity. So when thick syrup is poured over hot pancakes, the syrup becomes thinner and runs over the sides of the pancakes. When thick motor oil is added to a car engine, the oil thins out as the engine heats up. Olive oil, on the other hand, is very thin and it is almost watery. So to make it a little thicker, it can be placed in a fridge where its viscosity can be increased. And asphalt, which is road paving, materials are heated up and it makes them less viscous so that they can be poured easily before it hardens. And once it hardens, it becomes a solid, so it's very, very viscous. More properties of fluids, we have density. Density is the amount of matter in a given volume. So each substance has a different density, and because of each substance is made up of different particles, the density of a substance depends on its particles that it's made up of. So when we talk about density, it's usually mass density that we're referring to. So the mass density of an object is simply its mass divided by its volume. Density depends on whether an object is a solid filled with air pockets or something in between. So substances that have a higher density than the density that the substance is placed in will sink, and substances that have a lower density than the density that the substance is placed in will float. This is why cork floats on water, where rock does not, because the cork is less dense than the water in comparison to the rock, which is more dense than the water. So when we go to calculate density, density is equal to a mass divided by volume. Here we have the memory method. It is a simple equation to help you figure out and how to solve density problems. So here it is signified with a line over and circles around it. I teach you guys the triangle method, so you guys have a triangle there to fill in with your sheet. The same idea applies. You simply cover up whichever value you need to calculate, and the other two are shown in their proper placement. So to multiply or divide. So for example, if you cover up the m, it leaves you with dV, which is density times volume, and it'll give you mass. You can also check out by the way of units. It gives you there that density is grams per meters cubed, and if you times that by volume, which is meters cubed, then it leaves you with grams, which is the desired unit for mass. Next, we're going to talk about calculating here density. So one way to determine the volume of an irregular object is to measure its mass in air and then measure its mass in water and subtract the second measurement from the first. You then divide by the density of water. So we'll talk about that a little bit later. That's a little confusing. Another way, though, to determine the volume of an irregular shaped object is to submerge the object in a full container of water. The volume of the volume of the object equals the volume of the water that overflows. So this deals again with ships, because ships can float because they contain a large volume of air, so their overall density of the ship becomes less than the water, so it floats on that water. Next, we're going to talk about buoyancy.